Alright, so in today's tutorial video, we want to look at statistical methods for analyzing pairs samples in STATA. But before we proceed, I'll urge you to kindly take a look at my previous tutorial video on the flowchart for classifying data, because in that video tutorial, I illustrated and explained the data structure for pair samples, which will help you to catch up with everything that I'm going to do in today's tutorial video, okay? You can just click on the link in the card above or check the description of this video for the link, okay? So like the two sample data or the independent samples, we have parametric tests and non-parametric tests for analyzing such data. The same applies with paired data or paired samples. So the type of parametric test for paired data is known as the paired t-test or the dependent t-test, sometimes also called the repeated measures t-test. This test basically compares the means of two measurements taken from the same individual object or related units. For example, researchers may wish to compare the means of a pre-test or post-test samples in which a factor is measured before and after an intervention, or researchers may wish to compare the means of a crossover trials in which individuals are randomized to two treatments and the same individuals are crossover to alternative treatment. There are certain assumptions which must be satisfied before this test can be used. One of the assumptions is that the data must be continuous, and the next one is that the data, that is the difference of for the match pairs, follow the normal distribution. Okay, now let's take a look at the non-parametric test for paired data. This is known as the Wilcoxon Signed-Rank test. This test compares the medians of two measurements taken from the same individual object or related unit. So for example, researchers may wish to compare the medians of a pre-test or post-test samples in which a factor is measured before and after intervention, or researchers may wish to compare the medians of a crossover trials in which individuals are randomized to two treatments and the same individuals are crossed over to the alternative treatment. There are certain conditions which must be satisfied before this test can also be used. One of the conditions is that the data must be continuous, and the next one is that the data, that is the difference for the match pairs, does not follow the normal distribution. Now, another non-parametric test that can also be used for the pair data is the sign test, okay? So you have to take note of that. Now let's take an example. A psychiatric hospital performed an experiment to compare whether a record score in which instructions to form images of 20 words were given is better than an initial record score for which no image instructions were given. Some patients were randomly selected in the experiment with the results shown in the attached second dataset. Does it appear that the average record score is higher when imagery is used? We want to conduct a detailed statistical analysis for this problem in STATA, right? Okay, so now before we jump into our STATA window, this is where I have my Psycha dataset in this folder, as well as the do file for my paired data. So I'm going to link this data file in the description of this video so that you can download it, okay? And make sure that you have it in the same folder where you have your do file. So now let's jump into our STATA window. Alright, so I have my do file on the right hand side here. And the first thing that we want to do is to set our working directory. Okay, so basically what you have to do is to maybe go to your folder where you have your data file. Your path may be different from mine. Click on this path and copy this. Once you copy, you go back to your STATA window or your do file and paste it in this double quote. Okay, so make sure that you have it in double quotes. Right, so once you are done, you can then run this, Control D. So let's see the effect in our result window. Alright, so now we have set our working directory. So the next thing is to import our data set. So I'm going to use this function, import delimited, and the name of the data set is scicad.csv. Then I want to clear if there's any previous data set in the memory. I want to clear it and make use of only this one. So let's quickly run this, Control D. Let's look at the effect. Okay, so it's still compiling. Alright, so it's done. We have 6 variables and 25 observations. Now let's view our data set by making use of the browse function. So let me highlight this, Control D. So this is the data editor, which gives us the variables or our data set in a spreadsheet form. So we have basically the first variable, which is the ID or the individuals. Then we have gender, age, height, no imagery, and imagery. We are interested in these two, right? So the imagery, the no imagery variable shows the record score for the patient when no image instructions was given, while the imagery variable is showing the record score for the same patient when image instructions was used. So it is the same individual patient with two different measurements, and want to compare if the average record score is better when the image instructions was used. Okay, now one thing that you have to note here is that this data set is also in two groups. You can see the gender variable here. We have gender 0 and we have gender 1, right? So let's assume the gender 0 is for the female group and gender 1 is for the male group. So in our analysis, what we're going to do is that we will first of all determine the average record score for this group, which is the female group, group 0, right? And take their corresponding no imagery and imagery values, which ends here, right? That is for female. Then we do same for the males. So we have to highlight this part. These are for the males. Let me scroll down, right? And we'll pick the corresponding no imagery and imagery, that's the paired data, right? And try to analyze to see if this is better compared to this, right? Then in our final analysis, we are going to pick all the observations, the 25 observations. So we will consider all these observations, right? We'll consider everything and pick the corresponding no imagery and imagery, right? And pick everything here. We'll pick everything to see if the record score is better when imagery was used compared to when there was no imagery instructions. Okay, so that's basically what we're going to do. So now let's look at the structure of our data set. Let's go back to our do file. Alright, so let me close this. Scroll down. So we want to look at the structure of our data set. We are going to use the describe function. Control D. Let's look at the effect. So yes, we have 25 observations and the variables are 6. And if you look at the data type for the variables, they are all numeric, right? But we know that gender is a categorical variable. So let's explore more about the gender variable before we try to see if we can encode it or we can skip that. So let's use the codebook function. Control D. So yes. So for the gender variable is numeric, like the data type is numeric, which is quite okay. And we can see for the value 0 we have 14, and for the value 1 we have 11 of them. So we can maintain this without encoding it because it's not in a string form. If it was in a string form, then we can basically encode it, right, by converting it into a numeric type. But with this we are good to go. We can still make use of this without having challenges. Alright, so let's continue. Now the next thing I want to do is to add the difference of the match pairs to our data set. Okay, so we want to generate a variable known as diff, which is going to be the difference between imagery and no imagery. Okay, so let me highlight this and run this. Control D. Alright, so let's see the effect in our data editor. So this is basically what you have added. We have added another variable which is giving us the difference between this and that. Okay, so 6 minus 6, 10 minus 6, 70 minus 9, and these are the results that you see in here. So with this we are going to use it to basically test for the assumptions. Okay, so basically before we even start with our main analysis, we are supposed to do some exploratory data analysis, but I'm going to skip that for now. If you want to learn how to do EDA in STATA, you can watch out my tutorial video on EDA by clicking on the link in the card above or check the description of this video for the link. Okay, So I'm going to skip the UDA and proceed to the test for the normality assumption, right? So we want to start with parametric one. We know that already these are continuous or they are numeric, right? So we don't have to worry much about that. The next thing is to determine whether the difference for the match pairs is normally distributed, okay? But I want to start with group 0, so we want to start with group 0, which ends here. We'll pick the corresponding difference variable, this ones. Okay, so this is the end for group 0, right? So I want to start with group 0, then we'll come to group 1, then later we'll take all the observations. So let's go back to our data do file. So in here, we want to determine the average record score for group 0, right? So we want to test for the normality assumption. We want to start with a QQ-Plot. So in here, we want to use a QNOM function for the difference variable if the gender is equal to 0. So here it's going to pick only that of the difference variable for gender 0, okay? Alright, so let me scroll back. Now let's quickly run this, Control D. So there should be a window, yeah, a graphic window. Yes, so this is basically showing us the QQ-plot for the difference variable for the group 0 data set. And we can see that most of the points are on the straight line sloping upwards to the right. So this is an indication that the distribution of the match pairs for this data set is normally distributed, okay? Now another test that you can also use to check for the normality assumption is to make use of the Shapiro-Wilk test, okay? So let me scroll down. So in here I want to make use of the Shapiro-Wilk test. Right, and this time we are only looking for the group 0 or the gender 0, okay? So let's quickly run this, Control D. Let's look at the effect. So we are interested in this p-value. The null hypothesis for this test states that the distribution is normally distributed. So we want to basically compare this to the upper level or the threshold value at 5%. We only reject the null hypothesis if this value is less than or equal to the upper level at 5%. Okay, now because this value is greater than the threshold value or the upper level at 5%, it means that we are failing to reject the null hypothesis and conclude that the distribution of the match pair difference for this data set is normally distributed. Okay, so now we are certain that the normality test has been satisfied, so we can proceed and make use of the paired t-test, right? So let me scroll down. So we can state our null hypothesis as the mean record score for group 0 is the same when imagery is used, and the alternative can be that the mean record score for group 0 is better when imagery is used. In other words, you can also state it as, you can state the null hypothesis as the match pairs difference in the mean record score for group 0 will be equal to 0. And the alternative, you can state it as the match pairs difference in the mean record score for group 0 will be greater than 0, okay? So now let's look at the computation for the paired t-test. Alright, so this is going to be the function t-test. I want to find out if imagery will be equal to no image. This is going to help us get a null hypothesis, and we are picking it for only the gender group, okay? We are picking it for only the gender group. Now we are starting with the imagery variable first, because by computation it's going to be the first variable minus the second variable, okay? So basically this is what I mean. Once we specify the first variable first, this is how the null hypothesis will look like. So that the alternative, you can have it in this form, this first variable being greater than the second variable, okay? Or we can also have it in this form. Once we take the difference, it should be equal to 0, then the alternative should be greater than 0, okay? So let's go back to our do file and try and execute this. Alright, so let's try and execute this, Control D. Alright, so here we go. So we have this paired t-test result. Now we have the alternative hypothesis. This for the left t-test, this for a true t-test, and this for a right t-test. Now because we are having the right test, we want to find out if imagery is better, which means it's greater compared to no imagery. We have the right test. So we are going to draw a conclusion based on this. So I want to compare this p-value to the alpha level at 5%, and this, because this one is less than the alpha level at 5%, it means that we are going to reject the null hypothesis and conclude that the matched pair difference in the mean recurse score for group 0 is greater than 0. In other words, we can also state that there's enough evidence to indicate that when imagery instructions was used, the performance was better compared to when there was no imagery instructions for this data set for the group 0, okay? Alright, so now let's assume that the normality test failed. Assuming the normality test failed for this data set, then it means that we are going to make use of the non-parametric test, specifically the Wilcoxon Signed-Rank test, okay? So assuming the normality test failed, then the Wilcoxon Signed-Rank test will be, so this is the computation for the Wilcoxon. So let me highlight this. So it's going to be Signed-Rank imagery equal to no imagery if gender is equal to 0. So we are interested in only the gender 0, okay? So let's try and execute this. Control D. Alright, so let me scroll. Alright, so this is the result for the Signed-Rank test for this data set, for the group 0 data set. And in here we can see the p-value for it. This p-value is for a two-tailed test, so we are supposed to divide this by 2, and if you divide this by 2 you will get 0.026, right? So comparing this to the alpha level at 5%, it means that you're also going to reject the null hypothesis and conclude that there's enough evidence to indicate that the matched pairs difference in the median recurse score for group 0 is greater than 0, okay? So when imagery instructions was used, and the performance was better compared to when there was no imagery instructions, okay? So we are done with the first part. Now we want to determine the average recurse score for group 1. Now we are moving to the male group, okay? So basically we are done with the female group, this ones, okay? Now we are moving on to the male group to determine the average recurse score for this and pay the corresponding values here, right? So we are going to use this to test for the normality assumption and use this to compute the pair t-test, okay? So now let's go back. Alright, so we want to start with a test for the normality, and we are going to make use of the QQ-Plot. So let me highlight this. So now q-norm diff if gender is equal to 1. So control D. So here we go. So you can see that most of the points seems to deviate from the straight line, right? Some are also close to the straight line. So with this, you may have some doubt to know whether it is normally distributed or not. So let's try and make use of the Shapiro-Wilk test to confirm this result. So let me scroll down to Shapiro-Wilk test for gender 1. Control D. Alright, so here's the p-value. Comparing this p-value to the alpha level at 5%, it means that we are going to fail to reject the null hypothesis and conclude that the matched pairs difference, okay, the distribution of the matched pairs difference is basically normally distributed, okay, because this is greater than the alpha level at 5%, so we are failing to reject the null hypothesis. So from the QQ-Plot, we can also state that the distribution for the matched pairs difference is normally distributed, okay? Alright, so now that we are certain that the normality test has been satisfied, we can proceed and make use of the pair t-test for this data set. So we can state the null hypothesis as the mean recurse score for group 1 is the same when imagery is used, and alternatively we can state it as the mean recurse score for group 1 is better when imagery is used, okay? So now let's look at the pair t-test for this. So we have t-test, imagery, no imagery if gender is equal to 1, okay? So basically it's going to operate on this. here is going to pick these values. This for group 1. So it's going to highlight this. This is going to be the no image image. So we're going to pick this and this and try to find out if this is better compared to this. Okay. So let me try and execute this. So Control D. So here we go. So we are interested in the right tail test. So I want to compare this p-value to the alpha level at 5%, and this is obvious that we are going to reject the null hypothesis and conclude that the matched pairs difference in the mean record score for group 1 is greater than 0. Right, in other words, when image instructions was used, the performance was better compared to when there was no image instructions for this group. Okay. Now let's assume the normality test failed for this. Then basically we are going to make use of the nonparametric test and specifically the Wilcoxon Signed-Rank. So this is how the computation will look like. Okay, for gender 1. So Control D. So we're supposed to divide this p-value into 2, and when you divide this p-value by 2, we are going to get 0.0119. So comparing this p-value to the alpha level at 5%, it means that we are going to basically reject the null hypothesis and conclude that the matched pairs difference in the median record score for group 1 is also greater than 0. Okay. Alright, so now the last thing I want to do is to determine the average record score for all the observations. Okay. So now we want to consider everything, all the observations, the 25 observations. So I want to use the whole of this, right? We will use this one, the difference to test for the normality assumption. Then later we use this for the pair t-test or the Wilcoxon Signed-Rank test, the imagery and non-imagery. So we are considering everything here. Let's go back to our do file. So I want to start with the QQ-Plot. So this is going to be QNum of the difference for all the observations. So Control D. So here we go. We can see that most of the points are on the straight line sloping upwards to the right. So this is an indication that the distribution of the match pair difference for all the observations is normally distributed. Okay. Now let's take a look at the Shapiro-Wilk test. So Control D. So comparing this p-value to the alpha level at 5%, it means that we are failing to reject the null hypothesis and conclude that the distribution of the match pairs difference for all the observations is normally distributed. Okay. All right. So we are going to make use of the pair t-test. So the null hypothesis, we can state this as the mean record score for all the observations is the same when imagery is used, and alternative we can state it as the mean record score for all the observations is better when imagery is used. Okay, so now let's look at the pair t-test. So this is going to be imagery equal to no image. Okay, there's a double equality sign, so I have to take note of that. So let's try and execute this. Control D. Now we are interested in the p-value for the right tail test. So we are going to use this 0.0336 compared to the alpha level or the threshold value at 5%. It means that we are going to reject the null hypothesis and conclude that there's enough evidence to indicate that the matched pairs difference in the mean record score for all the observations is greater than 0. So when image instructions was used, right, the performance was better compared to when there was no imaging instructions for all observations. Okay. Now let's assume the normality test also failed for this data set. Then we are going to make use of the Wilcoxon Signed-Rank test. So this is how the computation also look like. So let me highlight this. Control D. So this is the p-value for 2 tests. We are supposed to divide this by 2. We are going to get 0.0019. Yep. So comparing this p-value to the alpha level, make sure that you divide this by 2. You get 0.0019. Yep. So when you compare the p-value to the alpha level at 5%, we are also going to reject the null hypothesis and conclude that There's enough evidence to indicate that the match pairs difference in the median record score for all observations is greater than 0. Okay, so basically when image instructions was used, the performance was better compared to when there was no image instructions. Okay, so this is basically how to perform a detailed statistical analysis for paired samples or paired data in STATA. Please, if you find value in today's tutorial video, don't forget to subscribe if you have not, and also turn on the notification bell to get more updates anytime I post on this channel. Thank you for watching.